This is the solution of the problem, projectile motion problem 1. So let's draw a picture of the situation. So let's see what we had. Here's the ball, initially thrown horizontally at 16.7 meters per second. Let's draw the ground. It is 1.50 meters above ground, and this would be the path. So let's treat this as two separate problems, x and y, but use the same techniques we've already learned. So we need a set of axes. In this case, I'm going to choose x to the right and y down for positive. That makes the most sense. We still need starting and ending positions, but we'll use two of them. Start x, end x, start y, and y. It's very important to make sure you train your brain when you're viewing y to only look up and down, and when you're viewing x, only look left and right. The problem said what is the range, so we're looking for delta x. So the technique to solve these problems is to separate into horizontal and vertical, or x and y, and see what we have. So let's look at the x direction. In the x, the principle of projectiles, v0 in the x, v in the x, and v bar in the x are all the same. They go together. You either know it or you don't. You should always have something written here, either a number or a symbol. We do know it this time. It's 16.7 meters per second. We also know the acceleration in the x is 0, because in the x direction it's constant velocity, and we are looking for delta x. The only equation that makes sense, delta x equals v bar x times t. Delta x equals 16.7 meters per second times t. So if we knew t, we could get delta x. This is going to come out of the y equation. So let's see what we know in the y. Let's choose the things that make the most sense to you first. For example, acceleration. Notice how I'm lining it up with the concepts we know on the left. The acceleration in the y, freely falling object, we called y down, so it's positive 9.80 meters per second squared. We know delta y. The displacement in the y direction is positive 1.50 meters according to our axis. The only other thing we know in the y direction is v0. v0 in the y is 0. It was launched horizontally, giving a 0 vertical velocity. In this problem, we now need time. And this equation makes sense to use. Delta y, v0 sub y times t, plus 1/2 ay, t squared. This term is 0, so we end up with delta y equals 1/2 at squared. Solving for t, t is the square root of 2 delta y over a. Now remember, we always get two answers with a square root, but we need to choose the positive since the negative doesn't make sense. Putting numbers in, the square root of 2 times 1.50 meters over 9.80 meters per second squared gives us 0.553 seconds, which is the time it takes to hit the ground. That's also the time it takes to fly horizontally. So let's substitute that in over here. And when you substitute that in, you get delta x equals 9.24 meters, which is a solution to the problem.